my dear students. Good morning. Hope so you are happy and safe at your home with your family. So, dear students, welcome to the world of chemistry. And this is your digital class, समय 10 से 12 वाला हर घर में पाठशाला, and this is your chemistry period as we are doing unit 4 chemical bonding and molecular structure. Today our topic is very important, that is hybridization and its types. So first, before going to start, let's start as usual with the positive mindset. Always end the day with a positive thought. No matter how hard things were tomorrow, tomorrow's fresh opportunity to make it better. Okay, so the meaning of thought is always end the day with a positive thought. Dear students, whatever is happening to you nowadays, don't bother about it. Just see and think like this way. I mean, God is there, Almighty God is there, and He will do everything smooth and safe. He will do everything right when the moment will come. Okay, just pass this day and wait for the nice days or good days or healthy days. So no matter how hard things were going today, so tomorrow is fresh opportunity to make it better. So without wasting any time, let's start. We are doing chemical bonding and molecular structure. So already you know very well about the definition of chemical bonding. Chemical bonding is a attractive force between two elements, which when wind, then they will convert into molecular structure. So their recap is whatever we did, molecular structure we did, and we are talking nowadays about theories. So basically three type of theories we are talking. First we did Vesper theory. Vesper theory is talking about the shape of geometry on the basis of bond length and lone pair and bond pair. Then we are talking about bond BBT now. Yesterday's video was about BBT, balance bond theory, where we had discussed about the overlapping of two atoms, and after overlapping they are forming bond, and after forming bond they are converting into some shape. Okay, today we will talk about hybridization. After that, last video is of molecular orbital structure. So basically we understood already the definition of hybridization. Hybridization is what? It is the intermixing of different orbitals. Intermixing of different orbitals having slightly different energies that give an identical shape and equal energy, which is called hybridization. There are basically different types of hybridization, that is SP, SP2, SP3, SP3D, SP3D2, SP3D3. It means that what is SP? Why name is there SP? It means that those atom which is going to be react, okay, those which atom is going to be combine, and after combination which is forming a molecule, those atom sharing electron from which orbital, on the basis of that the hybridization is there. Suppose if sp is there, it means that one atom is sharing electron from s, second atom is sharing electron from p, then it is known as sp. Okay, second is one is sharing from s and both side it is sharing from p, this is sp. Similar way sp3, similar way sp3 d2 also, like this way d2. Okay, so we will discuss in detail about all these shapes that I told you, that is types of hybridization. And let's start with the different types of hybridization. First is, what is hybridization? Hybridization is the concept of mixing of atomic orbital into new hybrid orbital with different energy, different shapes, then the component suitable for the pairing of electron to form chemical bond, that is valence bond theory. So there are different type of hybridization. One by one I will explain you. First is S.p.p hybridization. S.p.p hybridization is intermixing of one s and one p orbitals of almost equal energy to give two identical and degenerated hybrid orbital. You can see here, this is s, this is p. When these sp will combine, it is forming a hybrid. Hybrid is always the, I can say, the mix quality, mix breed. These sp hybrid orbital are arranged linearly and make 180-degree angle, which is called a linear shape. Okay, they possess 50% s, 50% p character. Hope so you understood.
Chlorine atom. The atomic number of chlorine is 17. The general electron configuration is
1s2, 2s2, 2p6, 3s2, 3p5.
the ground state electronic configuration is the two hybrid orbitals of beryllium from two sigma bonds with 3pz orbital of 2 chlorine atoms. Hence, the molecule gets linear shape,
Cl, Be, Cl.
bond angle of 180 degree. Therefore, both the bonds sigma
S.p.pz.
are identical with pair of electrons.
MgCl2. These are very basic example of this type of hybridization. Okay. Second is S.p.p, that is called sp2 hybridization. Now one S and 2 P is there, and it is forming trigonal shape. Okay, because 1, 2, 3 orbitals are overlapping, so it will give us the shape of like 3 molecule. Okay, the intermixing of 1s and 2p orbital is almost equal energy to give 3 identical and degenerated hybrid orbital known as sp2 hybridization. The 3 sp2 hybridization are oriented with trigonal planar with the bond angle 120 degree. So dear students, what type of questions are coming? Question which is coming in exam, that is coming, write the hybridization of suppose this molecule BF3. So you should know how many number is there, 3. Okay, it means that B is in the center, F is there. So this is the shape of BF3. This is called trigonal planar shape, and this is 120 degree. The angle is between each molecule is 120, and the sp hybrid orbital have 33.3% S character and 66.6% P character. Okay, next is sp3 hybridization. So now I think you understood the concept. What is the concept? जो यहाँ पर नाम है sp3 उतने ही यहाँ पर मॉलिक्यूल होंगे, लाइक sp3, तो p3 है, s एक है, तो that's why the name is sp3, and sp3 when will combine it will convert into one shape, that is tetrahedral. तो कितने हुए sp3? टोटल 4 हुए, एक s प्लस 3p, टोटल 4. तो 4 बॉन्ड होंगे, जितने मतलब ये है प्लस करके उतने बॉन्ड होंगे. So in sp3, 1s is there, 3p is there, almost equal energy intermixing, and sp3 orbital are oriented tetrahedral. Tetrahedral geometry is like this way, tetrahedrally, with the bond angle 109 degree, 28. Okay, the sp3 hybrid orbital have 25% s and 75% p character. After this sp3d hybridization, now what included? D included now. sp3d. So it means that 1s, 3p and 1d is there, almost of equal energy intermixing to give 5 identical degenerator. It is forming, for example, I will take example of PCl5. This is happening in PCl5. So PCl5 is example. P is in the center, Cl, 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 Cl and Cl. Cl will, 3Cl will make bond, trigonal, and 2Cl will not make, that bipyramidal. That's why the name of geometry is trigonal bipyramidal. Okay, trigonal bipyramidal. You can say among them 3 are arranged in trigonal plane, and 2 orbital are present in above and below the trigonal plane. sp3 hybrid orbital have 20% s, 60% p, 20% d character. sp3d2 hybridization, intermixing of 1s, 3p and 2d. So obviously hybridization is sp3d2, 90 degree is the angle, and you can see by visualization it is forming somewhere octahedral shape. This is octahedral, you can say 6 side geometry. Okay, this is octahedral, and example is SF6. This is the example. Next is sp3d2 d3. Now sp3d3. In sp3d3, 1s is there, 3p is there, d3 is there. So total how many bond? 7 bond will be there, and the 7 bond is forming, you can see, pentagonal bipyramidal. This is called pentagonal. Penta mean 5 is joining with each other and 2 is not. Pentagonal bipyramidal, in which 1s, 3p, 3d is there with same energy, and bond angle is 72 degree, and pentagonal shape is there. So this is next type of hybridization. So dear students, now I am going to compile, differentiate this hybridization with the valence bond theory. In valence bond theory, we were predicting the shape on the basis of bond pair, number of bond pair, and number of lone pair. Now here on the basis in hybridization, we are doing on the basis of uh, hybridization. Okay, like sp, in this way, how many sp is there? Suppose 1s 1p is there, so 2 electron pair, it means that linear. sp 1s 2p is there, it means that total 3 1s 2p plus 2 1 plus 2 3 trigonal perimeter. sp3 is there, 4 bond tetrahedral. sp3d, this is somewhere like with lone pair, it is exception. Total 5 bond and trigonal bipyramidal. sp3d2, total 6 bond octahedral shape is there. Okay, so I think you understood the meaning of hybridization and how it is helping us to determine the shape of molecule. So bond formation from hybridization is single bond. If single bond is there, that is end to end, it means that it forms sigma bond. In previous video we studied about sigma and pi bond. If double bond is there, it means that 1 sigma 1 pi is there. If triple bond is there, it means that 1 sigma and 2 pi is there. How are the 2 pi bond in the triple bond is oriented? That is you want to draw from your book. So this is beryllium chloride, which is showing linear structure. So you can see here 1s molecule is there, 2p is there. Okay, so this is beryllium is forming this shape, and 2 chlorine is reacting, I can say attaching, and it is forming this kind of shape. Okay, this is 3D shape you can make by how it is given in your book. BF3, it is trigonal planar. And if a valence bond theory I am telling, so you can see here boron is 5, it means that 1s2 2s2 2p1. So this 2p1 is here, you can see, and that 2p1 will going to be overlap with one electron of fluorine and forming the bond in this way. So this is basically trigonal. Okay, if I will make stand, so it will look like this way, it is trigonal shape. Okay, then after that NH3, it is tetrahedral, in which 1 is lone pair, this is lone pair, rest 3 is bond. Okay, so this is making this type of shape, it is NH3. You can understand here lone pair and bond pair, these are 2 lone pair and these are bond 3 bond pair. Okay, next is CH4, this is also tetrahedral without lone pair. So this is without lone pair, all side H is making bond, so one electron is free. These all you can say unpaired electrons, so one hydrogen will share electron and it will form tetrahedral. H2 is bent shape or B shaped, which is in which 2 lone pair and 2 bond pair is there. I am going to relate the hybridization with valence bond. This is hybridization and this is according to Vesper theory. Okay, these are lone pair bond pair is according to valence shell electron pair repulsion theory. PCl5 is trigonal bipyramidal, in which there is no lone pair, all are forming bond pair with p block elements. Then SF6 is octahedral. Once again, it is very important to understand how the electron bond are formed with each other. So this is the shape you can see now, you can imagine shape, this is imagine shape is of octahedral. Okay, this is octahedral shape, you can draw yourself in your book, in your notebook, sorry. This is octahedral shape, this is octahedral shape. Okay, this is the particular shape of this. After SF6 we will understand now. This is last. So hybrid orbital mean what? Key point we studied, the number of hybrid orbital obtained equal to the number of atomic orbital mixed, and the type of hybrid orbital, it depend upon the type of hybrid orbital depend upon the type of atomic orbital mixed. So basically we have sp, sp2, sp3, sp3d, sp3d2, sp3d 3 also is there, that is next type. So composition of and orientation of hybrid orbital, 1s 1p is forming sp, and that is 2, and it means that 2p is there, it is orientation like this way. So it is same thing that we are studying. sp2 is giving trigonal, sp3 will give tetrahedral, sp3 d will give us pentagonal, sp3 d2 will give octahedral. Okay, so check your progress now. Draw the following structure on the basis of hybridization now. Carbon dioxide, aluminum chloride, sulfur dioxide, PF5, BrF3 and IF5. Dear students, it's my request, everybody, all the students has to draw this structure and send it to me on my WhatsApp. Otherwise those student is going to be considered as absent. Okay, yesterday also I asked so many important questions, but a very few student has responded. So its loss is your. I'm going to record each and everything. When you will come online, I will ask you. Okay, so dear student, this was the last. Stay home, stay safe, take care of your family, be the corona warrior, don't be the corona carrier. Thanks for watching this video. Have a nice day. Thanks a lot.